Hello, my name is Rohit Chamle. My KID is K2055291. Today, I'm going to be presenting a report about data analysis. It's a part of our assessment for the module Applied Data Programming. So let's start with the presentation. In this presentation, I'll be covering a research report synopsis, practical report synopsis, and a few research questions. Um, in for our research report, we were provided with two data sets, one of which contained the features of buildings, and the other one contained the damage grade upon buildings. Our aim for the research report was to understand the data, like which of them are binary columns, uh, which of them which columns had categorical values, which of them had binary values. So we did that, and after that we had to come up with the 10 research questions um, to better understand the data and help the governments as well. The practical report, we basically were working with the data set where we performed IDA, EDA, as well as in IDA part we did some transformations, we did some merging, where we found that in the IDA part we found that there was an outlier in each column as well, and for in the EDA part we did handle this outlier with the median. So let's start. This was our approach. We first imported the data sets, both the data sets. We checked the value counts, and after checking the value counts, there were no missing values or something. So we went ahead and merged the data sets. After that, we checked for the normality of all the columns. We found the outliers as well for the age columns, and after that, we checked the descriptive statistics, minimum, more, maximum, and the nan values for the categorical columns as well. Uh, then after that we transform the data, not the whole data set though. We had to transform some columns because of the use of the categorical column in correlation. We had to convert the value of that categorical column into a numerical one. So after that we went ahead with exploratory data analysis, in which we had to handle the outlier in each column. After handling the outlier, the data was pretty much clean. So we take the correlation, and we used the heat map to print the correlation, where we found that damage grade, the correlation between damage grade and some other columns were high compared to the others. So we started uh, we started with the research questions, where we started plotting our research question answers through different types of plots, types of visualizations. So let's start with the research questions. We came up with the 10 research questions, but due to the time limit, I had to cut to the three of them only. First question is related: what is relatively safer floor count per foundation type across damage grades? So due to the plot limit as well, I had to skip one plot here. We divided the answer in three steps. For first step, we take the damage grade distribution of foundation types. So we found that the foundation type R uh, had the most count in all of the foundation types. So that's why the damage grade distribution was also high in this foundation type R. Like the damage grade 2 and damage grade 3 had more impact in the foundation type R. To check the percentage distribution, damage grade percentage distribution in the foundation types. So we went with the step 2, and we were using donut chart here. So here we can see that foundation type, all of these foundation types had the similar distribution of damage grades in all of them. So we can infer that the earthquake had similar impacts on all the foundation types. So for the further analysis, we considered foundation type R uh, to check the safer floor counts. Distribution of damage grade over floor counts on foundation type R. Here we are using tree maps to check the floor counts. You can see that the floor count 1 up until floor count 3, the damage grade 2 and 3 were okay, but after that the damage grade 2 had more impact on other floor counts. So from this, we can conclude that the earthquake had similar impacts on all the foundation types, as well as R is the most foundation type. That's why the count of the damage grade 2 and 3 were high, and we do recommend that for new development projects, foundation type with different floor condition should be analyzed first. Floor count more than 3 should be avoided for foundation type R, as the impact of a floor count on floor count 4, 5, and 6 were much greater. Let's move ahead with the question number 2. What is the safest other floor type and roof type combination across different grades of impact? Here we can we have used Plotly subplots, and we are using pie charts to show our visualization of data. First, pie chart shows the distribution of other floor types in across the all the buildings, all the infrastructures, where we can see that other floor type Q was widely used, like 63% of it, and the other four pie charts, we can see that the damage other floor type S had the least impact, because the damage grade 3 had the most impacts, and like all of them, J of other floor type J, Q, and X. Only the S floor other floor type had the least impact from damage grade 3. So we observed that other floor type Q and X, the distribution of the damage grades were similar in these cases, and for the other floor type S, damage grade 3 had the least impact. So we can infer that least impacted other floor type is S. For the question, we will consider other floor type S is the safest one, and move ahead with the visualization. For the step two, we are using stacked bar plot, horizontal bar plot, where we can see that roof type X, the combination of other floor type S with roof type X is the most impacted one, and the safest combination across all of them is that other floor type S with roof type Q across the damage rates. You can see here this one. Let's move ahead with the conclusion and recommendation. What do we recommend is that for the most impacted other floor type Q and X, quality of material should be a concern, and for the roof type X, it should be avoided for other floor type S. It is possible that foundation type might be affecting the other floor types. That need further analysis. Let's move ahead with the question number 3. What is most common position of high damaged buildings? It's basically only one step answer, but the thing is that we did check the percentage damage grade percentage distribution as well across all the positions, but I could include the plot here because of the plot limits. So in step one, we checked the positions. So highest position were used for the buildings or infrastructures is position S here. Uh, so we can conclude that position O should be avoided for new development projects. We concluded this on the basis of step two, and I'll show that in the code implementation. For other different positions, Other aspects like foundation type, superstructure should be tested before starting a new development as well. And this is my presentation report. So let's move ahead with the demo. Here we imported the datasets first from GitHub, and we understood the data. This was the part of research report. We understood the data. After that, in IDA, our most important content was the dataset merging, where we merged the dataset using a building ID column. Then we checked the normality of all the columns, and here we are visualizing them using the histograms. And here we are gonna find the outlier in column age. Here we can see that near the 1,000 age, there are some values. To handle uh, there must be some reason, that might be a data entry error or something. So to handle this outlier, we can just ignore the rows and replace them with median or mean. So we are going to do that in the exploratory data analysis. Uh, we did the transformation as well. Here we had to transform the few of the columns with the transformation to convert them into numerical values. uh, Here we checked for the nine values and handled them. Here, this is the part where we excluded the age below 300, and uh, allocated the median value for those age for those values whose age was more than 900, more than 300. Yeah. Here we can see that. After that, our next one was checking the correlation. We used the heat map, and we found that the correlation between damage grade column and few of the other columns like age, floor counts were high. Let's move ahead with the research questions. My question was question number 5. This is the first plot where we can see that the foundation type R is the most used one. That's why we are selecting this foundation type for the further analysis. We check the distribution as well, percentage distribution. This is the tree map. And for question number 6, this is what we have added in the presentation slides. Uh, there were only two graphs, so that we could include them. And just for the question number 10, we had to exclude this last plot, which was the damage rate percentage distribution or positions. So this is question number 10 here. We're checking for the number of which is the position which was highly used, across the buildings, highly damaged buildings. Um, yeah, and this is the pie chart uh, visualization. We are using plotly subplots here as well to check the damage grade percentage distribution or position T. So from here we can see that position O should be avoided for newer development projects. Why position O? Because the damage grade 2 was the highest here, and position G can be considered over position S in future constructions. It's because the damage grade 1 was more, and the damage grade 3 was less compared to the position S. And for the different position, other aspects like foundation type, superstructure should be tested. That's what I have already included in the PPT. Thank you so much.